Okay, so in question 6, we're asked students A and B are standing inside a train that is accelerating to the right with a magnitude of 2 meters per second squared, and student A throws a ball to the left towards student B with a horizontal velocity of the magnitude 4 meters per second. And at the instant the ball leaves the first student's hand, the speed is going 10 meters per second to the right, and the ball takes 0.5 seconds to reach student B, and we're asked to find the horizontal speed of the ball relative to the ground before it reaches the student. So, since we're looking at the speed relative to the ground, that means that the acceleration won't matter. So we'll just find the velocity of the ball by subtracting the magnitude of the train, which is 10 meters per second, minus the velocity of the ball, which is 4 and s, and that would look like that. So that means the velocity of the ball will be 6 meters per second, and that's B. And the mistake I made for this one was thinking that the acceleration of the train and the time it takes to reach the student would have a factor in this, and that resulted in me choosing A as my answer. And for number 4, it's asking the position and velocity of a car moving along a straight road are recorded as a function of time, as shown in the graph above. Which of the following correctly describes the car's speed and acceleration? So in order to find the speed, the speed is the magnitude of the velocity, so you can see here it's slowly decreasing the magnitude of the velocity, so that means the speed is negative or decreasing. And since the acceleration is the slope of the velocity, you can see that this is a line that's going in the positive direction, I guess, and that means that the acceleration is positive. And the mistake I made in this one was thinking that in increasing a positive acceleration would cause the speed to be increasing, and that's why I chose A as my answer. And for number 7, whereas the projectile 1 and 2 are launched from level ground at the same time and follows the trajectory shown in the figure, which one returns to the ground first and why? So in order to find how long it's in the air, we would look at the launch angle, and you can see that the angle 2 is less than angle 1, and that means that it was in the air for longer, because if you launch an item with a higher launch angle, that means it had a higher initial vertical velocity. And since this one was lower, that means it was launched with a lower initial vertical velocity, and that means it'll be in the air for less amount of time. And the mistake I made in this one was not knowing that we were only looking at the vertical velocity, and that was the only thing that has a factor in how long it is in the air. So I thought that we would need the relative initial speeds in order to find how long it was in the air for, and that's why I chose D as my answer. And for number 10, we're asked the figure A and B show two velocity vectors. A and B are the vector sums of the velocity vectors, and we're asked are the speed and velocity of A the same as the speed and velocity of B? For this one, we just add the vectors, and that means we get one like this and one like this, going in this direction, one going to the right. And since vectors are going in opposite directions, that means the velocities will be different. And the mistake I made for this one was thinking that since this one was going to the right, it would have a positive magnitude, and since this one was going to the left, it would have a negative magnitude. But I realized that I didn't know that the magnitude is always positive, and that made me choose this answer instead of the D as the right answer.